Hi folks, I was asked to put together a video about sketching logarithms, so I'm going to run through two examples to hopefully help those people who might be still having a little bit of trouble. The first thing to remember is what the base logarithm graph looks like. So this is the inverse of a exponential function, so an inverse is being reflected across the line y equals x. So you can see here my base graph of log to the base 10 of x would look something like that. If I change my base to a 2, it doesn't actually change the shape of the graph too much, and when we're sketching we don't have to do anything different to sort of somehow demonstrate a difference between the log of a base 2 and a log of the base 10. All that changes is the gradient of the graph. Okay, so where do we start this problem? Let's get back to putting my 10 in here, just so I'm working in the same space. We start with our base graph, and then from there we need to remember the effect that A, H and K has when we write our equations in a more complex form. Okay, so remember that A is a dilation, the H is a translation left and right, K is a translation up and down, and if I have a negative out the front, that'll be a reflection in the x-axis, and if I have a negative inside my brackets, that'll be a reflection in the y-axis. Okay, so let's have a look here and have a go at my two examples down below. So the first example is to sketch y equals 2 log to the base 10 of 3x. So let's just quickly run through these parts here. So this 2 is a dilation from the x-axis, and the 3 is a dilation from the y-axis. And the dilation from the x-axis will be by a factor of 2. And the dilation from the y-axis will be by a factor of 1/3, as we've discussed previously. Okay, so in this case we've got no translations, there's no reflections, so I'm actually just going to start with my base graph. Don't forget your asymptote and label the equation of the asymptote. And my base logarithm graph is like that. And you'll notice I didn't really take too much notice of where my x-axis intercept went, because what I'm going to do now is I'm going to solve this equation to find out what the value of the x-axis intercept is. And because of the shape of the graph, we can see we don't need to find a y-axis intercept. Okay, so x-axis intercepts, we know they occur when the y value equals 0. So if we substitute 0 into this equation, it'll look like this. The first thing I'll do is I'll divide both sides by 2, which leaves me with this expression. And then from there I can undo my log using an exponent. So it's 10 to the power of 0 equals 3x. Now you can either think of that about as using an exponent as an inverse function, or you can just say to yourself, right, this log means 10 to the power of what equals 3x, and the answer is 0. Or 10 to the power of 0 equals 3x, and we can rearrange that way. Okay, so next step, we've got rid of the log, doesn't look so complicated anymore. 10 to the power of 0 is 1, so my x-intercept will be at 1/3. So put that coordinate on the graph, and I'm finished my sketch graph of a logarithm. Let's have a look at the second example here. I just realised that my equation was supposed to be a plus there. So let's work through y equals negative log to the base 2 of x plus 3. So this time we have a translation 3 places left, and a reflection across the x-axis. Okay, so let's start with our base graph. Normally our base graph would have an asymptote at x equals 0. But if I move my graph 3 places to the left, that means my new graph is going to have an asymptote over here at x equals minus 3. And my base shape would normally be something like this. But again, not only do we have the translation left, we also have a reflection across the x-axis. So if I get that reflection, it actually changes my graph to look something like that. Didn't think too much about where my x and y axis intercepts are. Just sketched my graph because I'm going to find those axis intercepts now. So if I want to find out the x-axis intercept, same as before, the x-intercept occurs when y equals 0. So substitute y equals 0 into the equation, which would look like that. Divide both sides by -1, or multiply both sides by -1. Doesn't really matter which way you do that. It still equals 0. Then I would undo this log by using an exponent. It becomes 2 to the power of 0 equals x plus 3. And 2 to the power of 0 is just 1. And subtract 3 from both sides and you get -2. So my x-intercept is when x equals -2, y equals 0, and I write that on the graph as a coordinate. My y-intercept occurs when x equals 0. So we substitute x equals 0 into the equation, which would give me y equals a negative log to the base 2 of 0 plus 3. And I can simplify my expression a little bit to just make it negative log to the base 2 of 3. But without a calculator, I can't get an actual decimal answer here. So if we're working with exact values, the way I put that coordinate on my graph is I just simply say this axis intercept is when x equals 0 and y equals negative log to the base 2 of 3. And I can finish there. If you wanted to be clever, I could put that negative into the logarithm by bringing it up the top as a negative power and then rearrange that to get log to the base 2 of 1/3. It's equivalent to the same thing. Some people would argue that looks a little bit neater because I don't have the negative sign in front of it, but I kind of like the negative in this case because it lets me know that my answer should be on the negative y-axis. So that is graphing logarithms and finding the x and y axis intercepts. Hope it helps.